All right. Hi everyone, my name is Neeraja Rentichintala. I am a Director of Product Management in AWS Analytics. My co-speaker today is Mahesh Mishra. He is a Principal Product Manager on the SageMaker Lakehouse. Today we are super delighted to share with you more details about our newest launches, analytic launches at re:Invent, the SageMaker Lakehouse. How many of you have caught the Matt Garman's keynote around this announcement? Okay. So this is our agenda today. I will start with a brief introduction on the Lakehouse, so really talk about what are the customer problems Lakehouses are set out to solve, share our vision, AWS vision for the Lakehouse, and then I will briefly cover the features and the capabilities of the Lakehouse. Then Mahesh is going to dive deep on talking about how it works, some of the use cases, and also take us through some interesting demos. So as many of you know, generative AI is really driving innovation that is transforming organizations on how they scale their businesses and how they serve their customers. So companies now can much more easily create new experiences through conversational interfaces to information and applications. They can boost their productivity of the employees, of the users, by allowing them to do their work without having to really understand the underlying technology. They have ability to derive insights from vast amount of structured and unstructured data. And finally, the generative AI capabilities are important when it comes to the product ideation and the new product development. So when it comes to generative AI, there is really more to it than what it meets the eye at the first glance. What really enables you to derive value from generative AI is the data foundation. Data foundation is critical for enabling generative AI. Gen AI applications are still applications, so you need the operational databases to support the user experiences, performance, reliability requirements. You need your data lakes and data warehouses because this is where you are consolidating all your domain-specific data, and you need the right tool set to explore the data and also figure out how to leverage it for generative AI. And then there is the data integration, actually bringing the data together through streaming, batch processes, making sure that it's ready for your downstream consumption. And with generative AI, the data is in more hands than before throughout the organizations. So it's important to make sure that you have the right level of security, access controls, right quality, and also ensure that the data is meeting the privacy and the compliance standards of the organizations. And the models, we heard in the morning keynotes, a lot of things are happening on the actual models, Gen AI models itself, and they are growing at kind of extraordinary speeds. So however, the models are models. Again, you need a place to deploy them, you need environment to build applications using it. And what really makes the outcomes of the models unique, tailored to your business, is your data. So companies have realized the need for data and embarking on the data-driven initiatives. According to a Forrester report, more than 80% customers have adopted for roles like Chief Data Officer. A significant number of them have adopted, kind of embarked on the data-driven initiatives, and the ones that have seen success with them have accomplished up to 20% of revenue growth. However, it is clear that a significant number of customers start on their data journey, but they are not able to fully see the potential of what data can bring to them. So from an AWS point of view, we offer a comprehensive set of services, database services, analytics services, governance capabilities, and they offer rich capabilities. So customers appreciate the fact that we have this comprehensive tool set and also the price performance that is offered by AWS. However, we do hear from customers that if they want to accomplish their use case, build their workflows, it requires them to be builders. So it takes time to actually put together these use cases and the workflows that are required for their business requirements. So what we are trying to really, based on help the customers really meet these kind of evolving requirements with the transformation that they are looking for, the need for a unified experience. So customers want simplification in two dimensions. One is simplify the consumption of the services into a unified environment, bring all the tool sets together. At the same time, they need the simplification on the data side of things. And they want to accomplish this simplification without compromising on the rich set of capabilities as well as on the price performance. So let's start with the data, the focus for this particular session. Unified data management is hard. Customers like yourselves, they have data sources in many different places. They are trying to read the data from all these sources. They are trying to put together data pipelines, orchestrate these workflows, monitor these workflows to finally land it for analytics. The data lands in data lakes, data warehouses, and sometimes in both. So customers end up creating, to meet the different use cases, many copies of this analytics data. And customers create and manage these copies not because it's fun, because each of these systems are really optimized for specific use cases. So data lakes are really good when it comes to giving you the flexibility on the storage. They let you store the data in different open formats, and you have ability to access it using multiple engines. On the data warehouse side, they offer powerful transactional semantics, all the things that you would expect in databases. Then they offer very good SQL performance, and they are pretty easy to deploy for targeted use cases. So depending on where the customer started their journey, whether they are moving their on-premises big data deployments to cloud, or whether they are moving their on-premises data warehouses to cloud, they end up starting in one of these places. And as they evolve in their data journey, what we see is customers run into these kinds of issues. One, interoperability. They can't access all the data from all the engines. Second is inconsistent access controls. Because they have copies, they have to set up access controls on the data warehouse side and then on the data lake side, and then they have to have teams really to keep these things consistent. And because of the data copies and the duplicated governance, it ends up being complex architecture, and finally they all lead to really longer time to value, right? Being able to onboard new data sets, being able to onboard new use cases. So as customers progress on their data journey, these are some of the bottlenecks they hit, and which is where the innovation and the full potential of realizing value from data has friction. So what really customers want is Lakehouse. So how many of you have heard the Lakehouse term? So just to level set, the Lakehouses really kind of bring the best of both data lakes and the data warehouses, right? So as a customer, you are getting the flexibility and the openness of data lakes and the performance and the transactionalities of data warehouse, and you can use your choice of engines and tools on top of this data. You don't have to worry about data silos, you don't have to worry about the fragmented governance. So this is the promise of a lakehouse. So when we hear the definition like lakehouse term, typically this is kind of the intent, the lakehouse that is set out to solve. There are different options for lakehouse that are available for customers. Broadly, I would like to kind of categorize them into two buckets. One is like a data lake centric lakehouse, which means that these start as data lakes and added capabilities of a data warehouse. The other one is a data warehouse centric approach, where the solutions start as a data warehouse and then add data lake capabilities. So they all have their own pros. At the same time, we hear from customers that each of these approaches again comes with complex trade-offs. On the data lake centric approach, the continuous concern we hear from customers is that it takes away kind of decades of databases capabilities. Like you can't do things like multi-statement transactions, multi-table transactions. You just don't have those capabilities in this world. Another issue is interactive queries. It continues to improve, but still there is, when it comes to high concurrency handling of queries, there are performance issues with interactive workloads. And these systems also lack intelligent storage optimizations. So being able to really evaluate, understand your workloads, and optimize your data layout and provide recommendations for more efficiency. On the data warehouse centric, typically what ends up happening is the data that is there in the data warehouse is locked. You don't have open access to it. If you want to create the data in open formats in these systems, you don't have the full engine interoperability. So depending on how you write the data is going to decide who can actually read the data. So the engine choice is very much tied to the storage choice here. The net effect of all that is in these systems you still end up having data silos. So when we started thinking about Lakehouse, this is the new launch, it is generally available today. Our vision is AWS Lakehouse should have these 3 key tenets. It should bring together all the data unified. It should be accessible without limitations through open interfaces. And finally, it needs to have the right permissions, right security controls, so that the permissions are consistently applied irrespective of what query engine or the tool that you come through. Just to make it more tangible, the Lakehouse on the unification side, it brings together Amazon S3 data lakes as well as Redshift data warehouses. The second aspect, all this data is available through Iceberg API. So we are going to dive into that a bit more, which means that any Iceberg compatible engine, whether it is AWS like EMR or Glue or Athena, at the same time the third party applications are able to access this data across data lakes and data warehouses. And the Lakehouse also comes with integrated security controls, including the fine-grained permissions like row level, column level permissions, so that you can have kind of the centralized way to manage access to the data. One key point with the Lakehouse approach that we are taking is, as a customer, you don't have to make changes to your data architecture. So bringing data into Lakehouse is easy. Any data that you have in your data lakes or Redshift data warehouses is seamlessly available via Lakehouse. So you don't have to set up, per se, a Lakehouse. The data that you already have is available through the Lakehouse. In addition to the mechanisms that you typically use to load data into data warehouse and data lakes, you can also leverage our zero ETL capabilities to ingest data. We also have federated query capabilities that you can federate into other databases and applications. Zero ETL, some of you might know, a couple of years back, we pioneered this zero ETL vision, where we are able to much more securely and easily bring transactional data into your analytical stores for near real-time analytics. Many customers have successfully using this in production. And initially, we started with Aurora MySQL. Then we expanded support to multiple AWS managed databases as well as applications. So the benefit is through zero ETL, you can load the data into the Lakehouse and you can choose your storage format. It could be Redshift managed storage, RMS, or it could be open source S3 data. Another zero ETL approach is federation. In zero ETL ingestion, you are actually replicating data from the source systems. In the federation approach, you are doing in-place querying. So Lakehouse also offers federation capability. So these are some of the sources that we have available through zero ETL. We have support for Amazon databases, Aurora MySQL, Aurora PostgreSQL, RDS MySQL, DynamoDB, and we continue to expand those databases. The new announcement today, it was launched in the morning keynote, is now we have zero ETL from enterprise applications, 8 enterprise applications, including Salesforce, SAP, Zendesk, and a few others. So with this, again, the data you can bring into Lakehouse, you can keep it in Redshift managed storage or in S3 formats. And we support a few more databases from a federation perspective. So now that you have all this data coming from data lakes, coming from data warehouses, coming through federation, all this data is now accessible through Iceberg API. So you can set up your fine-grained access controls and you start accessing through Iceberg API. And these are accessible from the SageMaker Unified Studio, which again launched today, and also any third-party applications. Lakehouse is a key part of the next generation of SageMaker. So the next generation of SageMaker platform that we launched has 3 key components. One is the unified experience, which is called SageMaker Unified Studio, which is brings together all these different use cases. Then we have Lakehouse, which we are talking about it today, and then there is the integrated data and AI governance capabilities. On the SageMaker Unified Studio, the common workflows that you have in your data handling, things like data processing, SQL analytics, machine learning, generative AI application development. So all these things are available in a single experience. You don't have to go to different tools, different notebook environments, different query editors to do all of this. It's all available in a unified experience. And we have more use cases coming in that experience soon. And the nice thing is now your developers, you can basically much more easily collaborate and build faster. And all these types of workflows essentially leverage all the data that is available in the Lakehouse that we talked, spanning the data lakes and the data warehouses and the federated sources. So with this brief introduction, I'd like to hand over to Mahesh to dive deep here.
Thanks, Neeraja. Hi, everyone. My name is Mahesh Misra. I'm the product manager for the Lakehouse. And Neeraja did a great job introducing the Lakehouse. You probably have a good understanding of what are the core capabilities are. Now we are going to go a little bit deeper into how it works and what are those components that are available in the Lakehouse and mechanically how things are put together. So when you think about a Lakehouse, it's nothing fairly new. There are 4 components that exist in a Lakehouse. One is the storage layer. And in Amazon Lakehouse, there is a little different. We have flexible choices of storage in the storage layer. We have a unified technical catalog to manage all your data. And when we say technical catalog, think of them as these are metadata that query engines can understand, query engines can read to understand what is your underlying data layout. How many of you know what Glue Data Catalog lake formation today? Okay, so basically, historically, if you look at the technical data catalog that we had, it was a data lake catalog powered by Glue Data Catalog, and the lake formation was a permission on top of your data lakes. We extended the same capability into the Lakehouse world, where the same Glue Data Catalog and lake formation permissions can be applicable to all kinds of storage that you bring into your Lakehouse. And the third important component of your Lakehouse is permission, because you are managing data. You want your data to be secured, so most important part of data management is permission. So we have integrated permissions in the Lakehouse using the same primitives that we built 4 or 5 years ago with lake formation. And Iceberg compatible APIs. How many of you know what is Iceberg APIs, Iceberg REST APIs? Okay. So we are going to use, I'll discuss that in detail, but for now, these are Iceberg compatible APIs. So if you have a client library that's an Iceberg client library, it should be able to interact with those APIs, right? So these are the 4 components, like any other Lakehouse we have. The key part here is you have choice of what storage that you pick. You have a flexible catalog because you are picking your choice of storage. Your catalog has to be flexible to accommodate the organization of data in that storage system, integrated permissions, and Iceberg APIs. So let's understand what storage flexibility means. So until today, everybody who has a data lake uses S3 as the storage, right? We are going to support that, and it's supported on Glue Data Catalog today, on the lake in the data lake world today, and basically the idea here is customers who already have a data lake they should be able to continue to use their same data lake, storing their data in general purpose S3 buckets, and they can access the same data from the Lakehouse APIs, right? If you have Iceberg tables, automatic table optimizations will be readily available. I'll talk about that in a bit. And you'll have all the database style statistics management in the Lakehouse tightly integrated. That way, if you're running queries against your Lakehouse, you'll get the best performance out of it. And given it is open format, and also there is Iceberg API, data is easily accessible from AWS analytic engines and third-party query engines as well. The next storage option that we have, which is announced today in the morning, is S3 tables. In last few years, we have seen that many customers want to build transactional data lakes, and we have built this data lake storage for the transactional data lakes only. So S3, in this new announcement, they are now going to support tables as a first-class primitive, meaning historically, if you have seen S3 buckets or used S3 buckets, they have been files or object-level APIs. We are introducing a new set of new type of bucket where tables will be a first-class primitive, and those tables will be integrated with the Lakehouse as well, which is in preview. And the general TPS, in a general purpose S3 bucket, the TPS is 5,500 TPS, whereas the S3 table buckets will be 10 times more TPS. That way, if you have high throughput workloads, you can use this storage as an option. It is table maintenance is an out-of-the-box capability, no matter what data lake storage that you use. If your table is stored in Iceberg format, table maintenance such as compaction and snapshot retention will be readily available. It's exactly the same technology whether if you use general purpose S3 bucket, your Lakehouse will provide those optimizations like compaction and the snapshot retention. If you're using S3 tables as your storage option, it's the same technology, but it'll be done underneath the hood with S3. Then the third option, and the important part is how it differentiates from existing Lakehouses, is we are also bringing Redshift managed storage into the Lakehouse. What we have seen historically is customers have used data warehouses, and their data is already in Redshift's internal storage format called Redshift managed storage. These customers can bring their data over to the Lakehouse from there so that it can be accessed from other query engines as well, just like any other Iceberg table. We are also offering Redshift managed storage as a storage option. As a customer, I don't have Redshift, but I want to use Redshift storage options for my transactional workload. I should still be able to create new data sets using the Redshift managed storage. That option is available on the Lakehouse as well. And the benefit of Redshift managed storage is it's fully managed storage system. It's hands off the wheel for you. Automatic machine learning enabled optimizations are available. If you have a repeated query pattern that is running against your data sets, Redshift's optimizations will kick in, which is going to create automatic optimization data structures like automatic materialized views and accelerate your queries on these storage system. So some of the key use cases where Redshift managed storage is going to be better is near real-time ingestion. If you think about classic data lake storage, the challenge there is when you are writing near real-time data, you are creating a large number of small files, which needs additional maintenance procedures like compaction. If you are using Iceberg, you must be familiar with it. But with Redshift managed storage, that comes with the storage system itself. You should be able to write near real-time data without any additional overhead of a table management. Your data will be transactionally consistent, including multi-table transactions supported on it. We have, if you are using Redshift as the query engine on top of that storage, you are going to get 7x better throughput for BI analytics workloads, faster performance for small write workloads. We ran some benchmarking. We found it is in orders of magnitude, single digit orders of magnitude improved performance when we are running Spark workload against Iceberg S3 table compared to Redshift managed storage tables. Meaning Redshift managed storage is in orders of magnitude faster when you write small data files into small chunks of records into your Redshift managed storage. Similarly, your read performance is also improved. Our internal benchmarking shows we are almost half faster, 50% faster when you run Spark workloads on top of Redshift managed storage compared to open source Iceberg tables. Now you have 3 storage options. You picked your storage, right? You need a flexible catalog that can understand this data organization as well, right? So what we are doing here is the existing data catalog that we had where customers used to manage their data lakes, we extended that with more flexible data hierarchies. So this unified catalog, which is again Glue Data Catalog, now will offer you dynamic hierarchy to organize your data from these storage systems. Each catalog will represent a storage type. So basically, if you want a Redshift managed storage to be a storage option for your Lakehouse data, you will create a catalog. It's a container under which all your Redshift managed storage data will sit. If you want S3 table bucket, you create a container for that and use and store all your S3 managed S3 tables bucket data in that. Then you can create managed catalogs to create new data in your Lakehouse directly. If you are bringing external data sources, like you have a Redshift data warehouse that you are bringing to the Lakehouse, or you want to do query federation like Neeraj was talking about, if you want to bring some external data sources like MySQL or BigQuery, you should be able to bring that data into a federated catalog. Meaning you have a data source, you want to query that data source directly from your Lakehouse. All you can do is you create a connection to your data source, bring that data over, and mount it in a federated catalog. After that, Athena query should be able to access the federated data that is stored in a different data store. Here is an example of how the multi-catalog hierarchy looks like. Say you have a Postgres compatible database like Redshift, and you have within the Redshift data warehouse, your data is organized in 4-level hierarchy. You have a namespace, which is a Redshift cluster. Under that, you have multiple databases. You have under the databases, you have schema, and you have tables. Similarly, when you bring that data and mount it in a Lakehouse catalog, the Lakehouse catalog will automatically adjust to the hierarchy of your source system. Meaning the catalog will automatically get nested. Top level namespace will be mounted in a catalog, and databases will be subcatalog under them. Schemas will be databases, and tables will be tables. So you brought your data, you cataloged in a unified catalog. Now to secure your data, you need to be able to define fine-grained permissions or any type of permissions on the data. So with the Lakehouse, you are going to get integrated access control. What that means is you have support for fine-grained access control. You can control table-level access, column-level access, and cell-level access control. If you are using third-party query engines to access your Lakehouse because it is Iceberg compatible, you should be able to use any industry-leading permission management capabilities like tag-based access control or role-based access control. And you should be able to share the data in your Lakehouse across accounts, across organizations as well. Let's look at what fine-grained access control means, right? So if you have a table, it's a collection of rows and columns. You should be able to restrict access to specific columns. It can be an inclusion list or an exclusion list, meaning you can say, hey, Neeraj can have access to these 2 columns, or you can say Neeraj can have access to this table except for these 2 columns. So you can provide an inclusion list or exclusion list when you define these fine-grained column level restrictions. You should be able to define row-level policies saying a user who is in the US is entitled to see US data, but he is not entitled to see data in the European region. You can define those policies which are row-level policies, and when you combine the row and policy level, you can restrict the permission to a cell level as well. Tag-based access control is fairly an ontology model where you tag your data set saying, hey, here is the table which has PII data, or a column that has PII data, and then define permissions of those tags to specific users. You can say, hey, Mahesh can have access to PII data, Neeraj cannot, right? So you can define all those permissions on your data sets. These are industry standard permission models that you can use. Zero copy data sharing is basically you are sharing the data with a different account or a different organization without actually physically moving the data. That's the model that we are talking about here. And you can build hub and spoke architecture on top of it, where you have a centralized account where all your permissions live, and you can share the data with consumer accounts. You can do peer-to-peer data sharing, which is very popular in data meshes. You can continue to do that. You can also do, if you have a data monetization use case, you can share data with other organizations and monetize your data. You have a storage layer, you have a catalog, you have permissions. How do you access the data? So for SageMaker Lakehouse, we allow any query engine to access the data through an Iceberg layer. And these are Iceberg compatible APIs through which the query engine will understand the table and its underlying storage and automatically go to the storage layer to access the data. The way it works is it goes beyond your data lake storage. Today, any Iceberg APIs work on top of tables that are stored on S3 or any object store using Iceberg format. But our Iceberg APIs that we're introducing with Lakehouse can go beyond your data lake storage, meaning your data could have been stored in any storage system, including S3 tables or Redshift managed storage. You can access them via these Iceberg APIs. When an Iceberg compatible query engine comes, connects to your Lakehouse, it'll see those tables as Iceberg tables and access them just like any other Iceberg table through an Iceberg library in the query engine. So with that model, you can use any AWS analytics service. If you have open source Spark or any third-party query engine, you can bring those query engines, connect to the Lakehouse, and query the data without any issue. And we make sure that you always query the single copy of data. We are not making copies of your data in the system. So what is Iceberg API? Just to give kind of a quick trailer of what it is, and those of you know it is good, but those of you do not know, this is an open source API specification Iceberg community maintains, right? So it is community managed, not specific to any vendor, any catalog implementation. Community managed specification, which is providing a canonical representation of a data set which is compatible with Iceberg. We are using the same specification. What that makes you is your Lakehouse always remains open without any catalog dependency. Tomorrow you decide, I want to move my technical catalog to a different Iceberg compatible catalog, it's a configuration change for you. It's because your catalog APIs are consistent no matter which Iceberg compatible API you are going to use, because these are open source specifications. You don't have to maintain any specialized clients. These are REST-based calls that you are going to make to the server from the client side. And every Iceberg library knows how to interact with these APIs. You do not need to build any additional libraries, client libraries to use these APIs. So what you can do with this, with the Lakehouse itself, you should be able to, the pretty basic use case is you have a Redshift cluster, you are a Redshift user, you have a Redshift cluster, you have a petabyte of data or maybe a few terabytes of data sitting in your Redshift warehouse. You can bring that data into the Lakehouse. The moment you bring that data into the Lakehouse without moving without making any migration, that data will be Iceberg compatible and will be accessible by multiple compute engines. So the way you are going to bring your data into the warehouse is with a click of a button. It's not a data migration, it's just a metadata registration. After that, the Iceberg API plays the role, right? So you go to your Redshift cluster, you click on that button saying register my data warehouse with AWS Glue Data Catalog, which is your Lakehouse. And once you do that, you go to your catalog screen in the Lakehouse Lake Formation page, where you say, hey, you'll see a pending invitation saying, hey, someone actually want to register the data. As an admin, do you accept? And you simply go and accept and mount it in a catalog and define permissions. Once you do that, your data, without physically moving from its storage system, becomes Iceberg compatible because your Lakehouse has Iceberg APIs. You can now use any query engine, like other Redshift clusters, to access that data. You can use Amazon EMR, Spark. You can use Amazon Athena. Or if you want, you can use any open source query, Spark, or any other open source query engine that understands Iceberg to query the data from your data warehouse without making any data migration. Let's look at how it works in action. Here is an example where I have a data warehouse, and there are 4 data warehouses. I picked one which is storing my events data. As say, for example, I'm an event management company. I sell tickets, and all my event data is stored in this data warehouse. I'm going to show you some of the tables that exist in this data warehouse. And after that, we are going to publish that to the Lakehouse and see how it works. So I connected to the data warehouse. I have two databases there. Events data is the database where all my events related tables exist. And I have 8 tables in there. So I have tables such as sales, category, and date dimension, event in this warehouse. I'll show by querying some of the tables. Sales is my fact table where all my ticket sales data is stored. So this is my fact table. Let's take a count on it. Let's see how many records are there in this fact table. So I have probably 170,000 records on this fact table. Now what I'm going to do is I'm going to register this with the Lakehouse. And within a click of a button, all this data that is in my data warehouse will be registered in my Lakehouse. So the first step that I'm doing is I clicked on register, and then I go to the lake formation to accept the invitation. Here I see a pending catalog invitation. This is basically once you register your data warehouse, it tells like, hey, here is a pending invitation, accept it. And as admin of the Lakehouse, I'll go and accept it. I'll mount this entire data warehouse in a catalog. So all I need to do here is provide a name of the catalog, provide a description, then a data transfer role. A data transfer role is basically a role that enables you to access your enables your query engines to access the underlying storage and fetch the data out. So I use the data transfer role here. Then I define permission on it. I'm making myself admin on this, a super user. So what I'm going to do is I'm select my role, which is on the corner. I choose my admin role and make it a super user of that catalog. just stuck. And now I create the catalog. Now my entire warehouse, the data warehouse that I had, is mounted on the Lakehouse without any physical movement of the data. Within a click of a button, my warehouse may have petabytes of data. I can bring that data over into the Lakehouse with a click of a button. The moment the data shows up in the Lakehouse, they become Iceberg compatible for you. These are the tables that you saw earlier, right? These tables are showing up in your Lakehouse now. Let's see, once the data comes to your Lakehouse, how you can query from different query engines. Let's see if you can query from two different Redshift clusters. Because historically what you have seen is your data is within a Redshift data warehouse, and you have to manage explicit data sets to be able to query it from different data warehouses. Now let's see how I can connect to a different Redshift cluster. I'll be able to discover the data that I publish to my Lakehouse. I should be able to query. I have logged in as the same admin role for which the permission has been defined. I see that I have the events data at the catalog name has been mounted as a database in my, it's an external database in a new Redshift data warehouse. I should be able to query using that data warehouse. So you had data in one warehouse, now you are querying from a different warehouse because the data is registered in the Lakehouse, and Lakehouse is accessible to multiple different query engines. Similarly, I can go to a provision cluster, connect to that, and I'll see the same databases and I can query. These are the same tables, same database names. I should be able to query the same data. The gist of the story, right? So you can now build multi-warehouse architecture from your Lakehouse. If you are a customer who has been using Redshift as your sole data warehouse, all your analytic data resides there, you should be able to register your data with the Lakehouse, and you can access it from different computes. What benefits you are going to get? Now you can scale your workload. You can have a dedicated compute for your ETL workloads, dedicated compute for your BI workloads. As your user volume increases, you can have dedicated compute for your, say, ad hoc querying workloads. So you have the same shared data, multiple different Redshift clusters being able to access to it. Let's look at another use case. If you want to build a data lake by directly accessing your Redshift managed storage, you should be able to do that on the SageMaker Lakehouse as well. And the way you are going to do that is simply by creating a managed catalog. You go to your Lakehouse, you create a managed catalog, you set the storage property as Redshift, and after that, your data, your Redshift managed storage is exposed to the Lakehouse as an Iceberg compatible storage. You should be able to query your data from Iceberg compatible engines. And then any permission that you define on your Lakehouse will be enforced no matter what query engine that you use to access your data. Let's see a demo where I'm going to show you how you can create data in RMS catalog, how you can access your Redshift data from other query engines like Athena, EMR Spark, and other query engines. So this demo is using Amazon SageMaker Unified Studio. I have pre-created the domain. A domain is basically a portal that you create where all the tools are available for you to access the data in Amazon SageMaker Studio. And the portal is accessible from SSO, your single sign-on. You need to set up your single sign-on. In this case, my user is actually registered as a single sign-on user. I log into the Unified Studio. I have created a project. And the way to think about a project is it's a workspace for a team where data, engines, and users are in a logical container and work against it, right? So, and a project is the permission boundary for a group of people, right? Here, what happens when a project is created, the Lakehouse comes with it. It already has a lake catalog ready to go. If you want additional catalogs with different storage options, you can add. Here, what I am doing is basically adding a RMS catalog, which is going to give me a Redshift managed storage option on the Lakehouse. And then I can run some workload against it. What I am doing here is basically going to the same my Lakehouse in my console, and basically giving permission to the warehouse data that we brought into the Lakehouse. I'm just giving permission to the project role. That way I can bring my entire warehouse data into my project and work against it. So what I did is I went to that events data warehouse. I took the project role, give permission to it. Now that data warehouse data will be accessible in my project in Unified Studio. Then I can use the tools to query the data. See, my events data warehouse is now appearing in my project. Now, I can use any query engine, such as Athena, to query the data from here. I have options for query engines. I'm picking Redshift to query it. I should be able to query using Athena as well. So basically, your data, once they go to your Lakehouse, they can be queried from multiple different query engines. Just take a count. It is the same data set, so it should be 170,000 approximately. I'm querying the data with Athena as well. This is my Redshift data warehouse. Without moving the data, I'm querying using Athena. Because Athena sees these tables as Iceberg tables via the Iceberg APIs. I created that catalog, my events analysis, and when I check that catalog, I do not have any tables. Now, what I'm going to do is I'm going to use Spark to write data into this catalog. In this example, essentially what I'm doing is I have set up a Iceberg client connection to the catalog. It is my EMR cluster already has my glue already has my EMR cluster already has all the Iceberg libraries. I'm creating a connection to the catalog. I'm going to read from my data warehouse and write to the RMS catalog using Iceberg libraries. I'm going to create a brand new table, ticket sales by customer. And this is an Iceberg table with write format as Redshift managed storage. And I'm running a SQL with some transformation. I'm going to write it to that Iceberg table, which is powered by Redshift managed storage. Once the data set, this is Iceberg write, even though the data is stored in Redshift managed storage. Now you simply, I'm running a count on that table. Then we can go back to our Lakehouse. The new data that we created, we should be able to query using multiple other query engines as well. So on my Lakehouse, the table is created. That's the Iceberg table we created using Spark. Now we can use Redshift to query it. and Athena to query it. So key takeaway is with SageMaker Lakehouse, you have one common data management layer where all your data appears to the query engines as Iceberg tables. You should be able to access your data using any query engine of your choice. So if you have AI/ML use cases where you need EMR or Spark, open source Spark to be able to access the data, you don't need to copy your data over to open format. You should be able to directly access data via these Iceberg APIs. If you have use cases where you have powerful BI dashboards that you need to enable, you can use Redshift managed storage option as for your Iceberg tables, and you can use Redshift as the compute engine to get the best interactive performance on your data sets. The compromises that you have been making so far, where I have to either put my data in a data lake storage or on a data warehouse storage, those compromises are gone. You pick the storage for your primary workload. Interoperability is a given. Thank you.